Imagine standing in the center of a medieval city. Every major building around you, especially like those towering Gothic cathedrals, they're designed with a very specific psychological goal.
Oh, absolutely. To make you feel tiny.
Exactly. I mean, the soaring vaults, the shadows, that terrifying verticality, it is all engineered to make you feel completely at the mercy of the heavens.
Yeah, you weren't the center of the universe. You were just a fragile little speck looking up.
Right. But then, right around the year 1400, a group of rebel thinkers in Italy decided to just completely flip the script. They decided that buildings shouldn't just point to God. They should actually revolve entirely around you.
And honestly, it is one of the most profound psychological shifts in human history. We stopped building structures that intimidated us, and we started designing spaces that validated our capacity for reason.
So whether you are walking through a historic city right now, or, prepping for a design meeting, or you're just curious about why certain spaces make you feel a very specific way, this conversation is fundamentally going to change how you look at the world around you.
It really will change your perspective.
We are pulling from this fantastic source compilation today titled Humanism in Stone, Renaissance and the Rise of Architectural Theory. And our goal is to explore exactly how architecture broke away from that mystical medieval mindset and transformed into a rational mathematical science, one that was completely driven by the philosophy of humanism.
Yeah.
Okay, let's unpack this.
So to really grasp this, we first need to correct a very common misconception. Because it's incredibly tempting to look at the Renaissance and think, oh, they just dusted off some old Roman blueprints and said, let's do that again.
Right, the whole revival idea.
Exactly.
Yeah.
But the core thesis of our sources is that the Renaissance wasn't merely a revival. The actual revolution was the systematic codification of theory.
Meaning they actually wrote it down.
Yes. For the first time since antiquity, architects weren't just these anonymous master masons stacking stones on a job site. They were intellectuals. They were writing books.
Yeah.
They were laying down the absolute mathematical laws of design.
But I mean, before you can write the laws, you need a proof of concept, right? You need a spark. And let's be real, you also need a massive influx of cash.
Oh, definitely. You need the funding.
So let's look at the urban reality of places like Florence, Venice, and Rome in the early 15th century. You have these incredibly wealthy merchant families and powerful trade guilds, and they are suddenly swimming in capital.
And they want to show it off.
Exactly. They want to spend it on massive public works. It's this fascinating cocktail of civic pride and honestly massive personal ego. Like, they want to honor the divine shore, but they also want every rival family in Florence to know exactly how rich and tasteful they are.
It was a fiercely competitive environment. And crucially, those wealthy patrons were funding humanist scholars. So these scholars are out scouring monasteries, finding, translating, and annotating these classical Greco-Roman texts. So suddenly, the builders of the day are exposed to this incredible philosophical and geometrical foundation.
It's like a knowledge explosion.
It really is. They start looking at the Roman ruins scattered around them, the Colosseum, the Pantheon, not just as piles of old rubble, but as encrypted messages from a superior civilization.
Which sets the stage perfectly for the man who essentially lit the match for this entire movement, Filippo Brunelleschi.
Yes, the ultimate proto-theorist.
That's what the sources call him, yeah. He's out in the dirt of Rome with a measuring tape, treating these ancient ruins like alien technology that he literally has to reverse engineer.
It's a great way to put it.
And from those measurements, he creates a brand new mathematical operating system for human perception. He invents linear perspective. But I want to make sure we understand how monumental that is. Like, how exactly did linear perspective change the way people literally saw the world?
Well, before Brunelleschi, medieval artists painted based on theological importance.
Meaning what, exactly?
Meaning, in a medieval painting, Jesus, or a king, is painted physically larger than everyone else, regardless of where they are supposedly standing in the scene.
Oh, wow. So space wasn't literal. It was hierarchical.
Precisely. What Brunelleschi did was mathematically prove that three-dimensional space could be plotted on a two-dimensional surface using a vanishing point and a grid.
That is wild.
It is. He proved that human vision follows strict geometric rules. If you know the math, you can perfectly simulate reality. It signaled this absolute unshakable trust in human reason and geometry.
And he didn't just apply that trust to a canvas either. He applied it to one of the most terrifying construction sites in history, the Florence Cathedral, Santa Maria del Fiore.
Oh, the dome.
Yeah. They had this massive 140-foot wide octagonal gap over the crossing of the church, and it had just been sitting open to the rain for decades because literally no one knew how to put a dome on it.
Right, because the sheer scale of the gap was the problem. The traditional medieval way to build an arch or a dome was to build a massive wooden framework underneath it.
Centering, right.
Exactly, centering. You lay the stones over the wood, and then you remove the wood once the mortar dries. But the gap in Florence was so huge and so high up that there literally weren't trees tall enough or strong enough in all of Tuscany to build the centering.
So you have to suspend millions of pounds of brick in midair, curving inward, with absolutely nothing holding it up from below.
Yeah.
How do you possibly build that without it just collapsing inward and crushing everyone?
Well, this is where Brunelleschi acts as the engineer of the impossible. He devises a double shell masonry dome, but the real magic is the brickwork.
The herringbone pattern, right?
Yes, he uses a specialized herringbone pattern. Instead of just laying bricks in flat, horizontal rings, he inserts vertical bricks at regular intervals. It creates this spiral that weaves up through the dome.
Wow, so what does that actually do structurally?
It acts like a series of internal interlocking chains. As the courses of brick go up, they lock themselves into compression. So the dome literally supports itself ring by ring as it's being built.
That is just incredible.
He even had to invent a completely new, reversible, gear-driven hoist, powered by oxen, just to get the incredibly heavy sandstone beams up to that height.
Okay, it is mind-blowing. But wait, let me push back for a second. If Brunelleschi is just taking his measuring tape to the Pantheon in Rome, figuring out how the ancients did it, and then coming back to Florence, isn't this just a giant copy-paste job from antiquity?
People assume that.
Right, like, how is it revolutionary if the Romans already built massive domes?
What's fascinating here is that it wasn't a copy-paste job at all. The Romans built the dome of the Pantheon by pouring concrete into a massive wooden mold.
Oh, right, and that recipe was lost.
Exactly. The knowledge of how to make that Roman concrete had been lost for 1,000 years. Brunelleschi had to span an even more difficult shape. An octagon, not a circle, using thousands of individual bricks and stones, and without the luxury of a wooden mold.
So he had to invent a whole new way of doing it.
Yes, he was taking the vocabulary of the ancient world, the scale, the ambition, but he had to write an entirely new structural sentence to make it happen. He proved that a rational, mathematical approach could actually solve physical impossibility.
Okay, so Brunelleschi proves it in stone. He builds the impossible. But a physical dome in Florence is kind of a localized miracle, you know?
Right.
Like, if you are a builder in Paris or a wealthy merchant in London, you can't just walk over and look at the herringbone brickwork. If this mathematical revolution is actually going to spread, you have to package that physical building and turn it into data.
You have to write it down.
Exactly.
And that requires a shift from the master builder to the intellectual theoretician. Enter Leon Battista Alberti.
Alberti, the guy who wrote the code.
Yeah, around 1452, Alberti writes De Re Aedificatoria on the art of building. It's the first major architectural treatise since antiquity. Alberti essentially takes architecture and completely rebrands it.
How?
He elevates it from a dirty manual trade into a liberal art. He says that architecture isn't about hauling stone. It's an intellectual pursuit grounded in reason, harmony, and a concept he called consonitas.
Consentitas, yeah, the sources define this as the beauty of well-fitting parts.
Yes, it's the idea of absolute perfection. It means a building is so mathematically cohesive that nothing can be added, removed, or altered without making the whole thing worse.
Oh, wow. So you can't just tack on an extra window because you want more light.
Exactly. It's like Mozart's symphony. You can't just remove a few notes without destroying the entire composition. Alberti leans heavily on the ancient Roman writer Vitruvius, adopting the Vitruvian triad commodity, firmness, and delight.
But he adapts it, right, for Christian society.
Right. For 15th century Christian society, a building must serve its human purpose, it must be structurally sound, and its beauty must elevate the human spirit.
And what's fascinating is how he translates this written code into actual physical manifestos. Like the Rucellai Palace in Florence is a perfect example of this.
Probably.
He designs this townhouse facade using superimposed pilasters. And for you listening, pilasters are those flat, decorative columns attached to a wall. He takes the exact organizational logic of the Roman Colosseum, where the columns change style on each floor as they go up, and he just flattens it onto a domestic townhouse.
That's brilliant.
He is literally taking the civic order of an ancient empire and applying it to daily domestic life.
Or consider the Church of San Andrea in Mantua. Instead of a traditional Gothic church with a bunch of skinny columns blocking your view, Alberti resurrects the colossal scale of the ancient Roman basilica of Maxentius.
So, massive open spaces.
Right. He uses a massive, uninterrupted, barrel-vaulted nave. He is using the architecture of ancient Roman law courts to create a completely new, kind of monumental, rational Christian space.
Okay, here's where it gets really interesting. I want to dig into the math here, because Alberti basically writes the grammar and syntax for all of this.
He does.
The sources detail how the Renaissance standardized the 5 orders of architecture: Tuscan, Doric, Ionic, Corinthian, and Composite. And these aren't just decorative choices.
Oh my God.
They dictate the exact proportions of a building. And it goes even further into modular proportion. They were completely obsessed with specific ratios, like the golden section, or a 1-to-2 ratio.
Right.
They were designing the heights, widths, and lengths of rooms to act as harmonic solids, literally mirroring musical consonants.
Yes, exactly. A 1-to-2 ratio is a musical octave. A 2-to-3 ratio is a perfect fifth.
Oh.
When you stand in a room designed with these proportions, your brain processes the spatial relationships the exact same way your ear processes a harmonious musical chord. They were quite literally designing frozen music.
Okay, but let me ask you this. If every single window placement is locked into a golden ratio and the height of every ceiling has to strictly mirror a musical octave, doesn't that mathematical rigidity totally stifle the architect's creativity? I mean, it kind of sounds like painting by numbers.
I get why you'd say that. To a modern mind, it might feel rigid. But to the Renaissance mind, it was the ultimate freedom.
How is that freedom?
Because they deeply believed that these mathematical ratios weren't just arbitrary rules made up by humans. They believed these ratios were the underlying source code of the universe.
Oh, I see.
By tapping into musical consonants in the golden section, they believed they were aligning their earthly buildings with divine cosmic truth.
Wow. Okay, that is profound.
And this leads to a massive underlying insight of the era. Order in a building was explicitly equated with order in the soul and order in the state.
So it's not just aesthetics.
Right. This wasn't just about making a palace look pretty for a rich merchant. It was a profound ethical stance. They genuinely believed that bad, chaotic architecture could cause moral decay.
Wait, really?
Yes. And conversely, a perfectly proportioned building would physically shape the people inside it into better, more rational citizens.
A well-proportioned building makes a well-proportioned citizen. That is such a powerful idea. But there is a bottleneck here, right? Alberti wrote this foundational code, but he wrote it at incredibly dense, highly erudite Latin, and without any pictures.
Which is a huge problem.
Right. If this idea that architecture can shape morality is going to reshape the globe, it has to be democratized. It has to go viral.
And to go viral in the 16th century, you need the printing press, and you need pictures.
Yes.
As we move into the High Renaissance, the ideas become universally accessible. You have architects like Donato Bramante designing the Tempietto in Rome, this small, perfect circle of Doric columns marking the site of St. Peter's crucifixion. It is theology rendered purely as geometry.
But the real shift in communication comes a little later, right?
Exactly. It comes with Sebastiano Serlio.
Yeah.
Starting in 1537, he publishes his 7 books of architecture. He translates Alberti's dense Latin into conversational Italian, French, and crucially, he fills the books with clear, beautiful diagrams.
He makes the first illustrated manual.
He does.
But the architect who truly perfects this, the man who makes the code truly universal, is Andrea Palladio.
Palladio is arguably the most influential architect in human history. In 1570, he publishes the 4 books of architecture. He takes the Vitruvian rules, his own measurements of Roman ruins, and his practical experience building in the Veneto region, and he synthesizes it into a highly adaptable system.
You know, when I was running the sources, my immediate thought was that Palladio essentially created the first open source software for housing.
Oh, that's a brilliant way to phrase it.
Like, he didn't just give you a blueprint for one specific, really expensive palace, he gave you the underlying formula. If you were a wealthy lord, you could plug marble and gold into Palladio's formula. But if you were a lower-tier nobleman, you could plug cheap brick and stucco into the exact same formula, and it would output a perfectly harmonious building either way.
That is the perfect way to look at it. It's parametric design before computers even existed. Look at his Villa Rotonda. It's a perfect cube with 4 identical temple-like porticos on each side, enclosing a central circular dome.
A circle inside a square.
Exactly. It represents total, symmetric, cosmic balance.
And then you have the Villa Barbaro, which is wild because he integrates a working, dirty agricultural farm directly with a pristine, humanist, noble residence.
Right.
He puts the manure and the tractor, well, you know, the 16th century equivalent of tractors, right next to the beautiful frescoes. The architecture serves as both an economic engine and a philosophical retreat.
It's incredibly practical.
But I have to ask, if Palladio is just handing out a plug-and-play template for any budget, doesn't architecture lose its bespoke, magical quality and just become a commodity?
This raises an important question. But no, it didn't lose its magic. And Palladio's genius prevented it from becoming soulless because the system was so robustly tied to human scale.
Meaning what, exactly?
It wasn't about mass-producing identical boxes. It was about ensuring that no matter the budget, the proportions remained dignified. It was the ultimate democratization of design.
And that's why it spread everywhere.
Exactly. That's why it spread globally. When Palladio's treatise was translated into English in 1715, it completely defined Georgian Britain. It shaped colonial America. I mean, Thomas Jefferson's Monticello is heavily Palladian.
Oh, right.
The system worked everywhere because human perception of harmony is universal.
That adaptability is just incredible. But this logic of proportion and harmony couldn't remain contained to just single villas and churches. It had to scale up to the size of entire cities.
It did.
Primarily because of a very harsh, very loud new reality on the ground: gunpowder.
Yes, the invention of gunpowder artillery completely shattered the medieval world. For centuries, cities were protected by tall, flat, relatively thin stone walls.
Right.
But a 50-pound iron cannonball fired at high velocity will turn a tall, flat wall into shrapnel in a matter of hours.
Right, because a flat wall just absorbs the entire kinetic energy of the cannonball.
Exactly. So Renaissance engineers, like Francesco di Giorgio Martini, had to merge architectural theory with military science. They started designing the Tres Italienne, or the Star Fort.
The ones shaped like giant stars.
Yes. Instead of tall, flat walls, they built low, incredibly thick, sloped earthen bastions shaped like the points of a star.
And the mechanism there is brilliant. The slope of the wall deflects the kinetic energy of the cannonball upward rather than absorbing it. And those jagged star points aren't just for looking cool from above.
Oh, not at all. The angles of the star points were mathematically calculated kill zones. They allowed the defenders to create overlapping fields of crossfire. There were 0 blind spots.
So if you attack...
If attackers rushed one wall, they were instantly flanked by fire from the adjacent star point.
What blows my mind, though, is that they didn't just design the defensive perimeter. They redesigned the entire city inside the walls.
Yes, the ideal cities.
The sources show these ideal city diagrams, places like Sforzinda or Palmanova, and they map civic virtue directly onto these radial geometric grids. The streets emanate perfectly from a central public plaza straight out to the points of the star fort.
It is the absolute seamless fusion of political philosophy, military defense, and urban design.
And this is where we see the most direct link to our modern world, isn't it?
Definitely. These Renaissance thinkers believed that by aligning architecture with human scale and rational thought, they could actually optimize human life. They were anticipating what we now call user experience, or UX, as well as evidence-based design.
So what does this all mean? Like, if you are walking through a 16th century star-shaped fortress, or you're reading Alberti's rules about how wide a doorway should be, how does that actually connect to how we experience the layout of a modern hospital, or even the digital interface we use on our smartphones today?
It all comes down to the underlying philosophy of the user.
Okay.
The Renaissance established that design must be rational, measurable, and fundamentally focused on the human being interacting with it.
Right.
So when we lay out a modern hospital to reduce patient stress by carefully calculating the distance between nursing stations and patient beds, or when a UX designer arranges a digital interface to naturally guide the human eye using a grid, we're relying on that exact same Renaissance assumption.
That's amazing.
The dialogue between stone and scholarship that began in the 1400s taught us that spaces, whether they are physical or digital, must honor human dignity and human perception.
It really is an epic journey. We've gone from the terrifying mystical verticality of the Gothic cathedral through the impossible self-supporting brickwork of Brunelleschi's dome, all the way to the open source formulaic manuals of Palladio that literally built the modern world.
It's massive.
Whenever you, the listener, walk through a thoughtfully planned city grid, or you step into a room where the proportions just magically feel right, you are stepping into a humanist treatise brought to life.
The math is invisible, but you feel it everywhere.
You absolutely do. But I want to leave you with one final thought to chew on. Building on this incredible evolution, as we've discussed today, the Renaissance famously elevated the architect. They took the master mason out of the mud and turned them into a brilliant theoretician working with pen, paper, and intellect. But looking at our own era right now, we are actively developing artificial intelligence systems that can instantly generate mathematically perfect floor plans, optimize complex user flows, and render hyper-realistic 3D models from a simple text prompt.
It's happening fast.
So, are we about to witness the next great architectural shift? Will the modern architect be moved out of the design process entirely, transforming from a Renaissance theoretician into a mere editor of algorithmic imagination?
It's definitely a wild thought.
It is definitely something to think about the next time you walk into a beautiful building. Keep looking closely at the structures around you, and we'll catch you next time.